7 squared is not equal to 25. Why would I even say this? Well, I see students do this all the time. Um, I have two statements. One is 7 squared is not equal to 25, and sometimes I write it this way. The square root of 25 is not equal to 7. I'll look at both of these things and see where it comes up. Right? Notice, 7 is equal to 3 times 4. Oops, so let's say 7, not 3 times 4, but 3 plus 4. So if I square 7, that should be 3 plus 4 squared, which is 3 squared plus 4 squared, which is 9 plus 16, which is 25. Now, something in this calculation is wrong. Something about this isn't right, because clearly 7 squared is not 25. 7 squared is 49, right? And 25 and 49 generally aren't the same number. So what is wrong here? Likewise, over here, it's a similar kind of thing. It's just backwards, but I see people do this all the time, where they look at 25 and they think of it as as 9 plus 16, which would be the square root of 9 plus the square root of 16, which is 3 plus 4, which is 7. But clearly the square root of 25 is not 7, right? Square root of 25 is 5. So what's going wrong here? Or why would people be even doing this? Generally, people don't make this mistake with numbers. They'd add the 9 and the 16, they get 25. But if they had something like this, if they had the square root of, x squared plus 4, they might be inclined to write it as x plus 2. But this is wrong. This is wrong. You can't just take the square root of a sum as the sum of the square roots. Likewise, over here, if you had something like the square root of a plus the square root of b and you squared it, right? Is that a plus b? Is that just a plus b? Well, no, it's not. The thing is, literally, this means the square root of a plus the square root of b times the square root of a plus the square root of b. And what you've got to do now is you've got to FOIL it out. So the first square root of a times the square root of a, all right, that's a. But the outsides and the insides, you end up with plus 2 times the square root of ab, and then plus square root of b times square root of b, which is b. So it's not just a plus b, it's a plus b plus this stuff, right? So this comes up because we're dealing with a implicit differentiation problem here, and a suggestion was made to square both sides to get rid of the square roots. Well, if you square both sides, if you take this thing and square it, you're going to get 3x plus 2y. You're going to get 3xy, but you're also going to get this middle term here. You're also going to get plus 2 times the square root of this times that. And whatever this number is, 7.205 squared. It's not going to matter. I'm going to take a square root. I'm going to take a derivative in a moment, and this is going to go to 0. But still, you don't get rid of the square roots. So if you tried doing this problem by squaring both sides and leaving out this term and saying that this equals that, and then implicitly differentiating, I don't care how you plug your numbers in, it's not going to work because you're going to have the wrong formula here. Squaring both sides and then implicitly differentiating is okay to do, but square both sides correctly.